Okay, Algebra 1. We are kind of moving on to the second part of our chapter. We're going to be dealing with rates and ratios, proportions, percents, a lot of different things from the very first part of our chapter. So today we are doing section 2.7, the notes, the rates, ratios, and proportions. These are things that I think are really useful, and I know that my husband and I both use in everyday life. So our objective today is to be able to write and use ratios, rates, and unit rates, and to be able to write and solve proportions. So the first example, we are using a ratio. A ratio is basically a comparison of two quantities. So this one is the ratio of teachers to students. So one thing that I do a lot of times when I'm given information, and then just so you know, you can write a ratio like this. We could also write this like this, and that's how we're going to use it today. So if the ratio of teachers to students is 1 to 15. So for every 15 students, there's one teacher. If there are 675 students, we're going to use this proportion, and the students are going to go on the bottom where the other section is. So 675 goes down here. And our unknown, this is what we don't know. How many teachers does there have to be? And so I have to take and divide and multiply. So we are going to use cross multiplying. So you multiply the two numbers that are across from each other, and we divide by that guy. So this is where we actually get to start to use our calculators. I'm going to go grab mine. Hold on. So 1 times 675 is 675, and then we're going to divide it by 15. So we get 45. So that means this answer here is 45. 45 what? They are teachers. The next one, the ratio of games won to lost. And you have to keep them in order. For a baseball team is 3 to 2. If the team won 18 games, so the 18 is going to go on the top, we want to know how many did we lose. So again, you multiply the two numbers that are across from each other, 2 times 18, and you divide by 3. So 2 times 18 is 36, divided by 3 gives us 12. So they lost 12 games. Okay. So that's kind of how you use ratios to find the missing values. The next little section here, we are finding unit rates. And a unit rate and a unit price is always per 1 unit. So for example, it says Takiro Kobayashi of Japan ate 53.5 hot dogs in 12 minutes to win a contest. Find the unit rate in, they want to know hot dogs per minute. Round to the nearest hundredth. So again, we can use a calculator. So our number of hot dogs was 53.5. And I really like to label things just so that I remember what I'm dealing with. And the minutes was 12 minutes. Okay, so we're going to take 53.5 divided by 12. And you get 4, and they say to the 100th, so it's 2 decimal places. So 4.45, but the 8 makes the 5 go up to a 6. So this is 4.46 hot dogs per minute. Crazy that they could eat almost 5 hot dogs a minute. So this one is a unit rate. Corey earns $52.50 in 7 hours. So they want to find the unit rate in dollars per hour. So again, $52.50 divided by 7 hours. So 52.5 divided by 7, and I get $7.50 per hour. That was his pay. Okay. Now, kind of taking unit rates, we're going to go back to dimensional analysis. This was something we did in 7th grade. We are going to convert what they give us to a different label, basically, or a different measure. So it says a large adult male human has about 12 pints of blood. Use dimensional analysis to convert the quantity to gallons. So we want to go from pints and we want to get to gallons. Okay, so one thing that we talked about last year was kind of understanding how to get from pints to gallons before you do any actual math. So for example, I would probably go from pints to quarts to gallons. Okay, and I know there are 2 pints in 1 quart, and there are 4 quarts in 1 gallon. So we start with our 12 pints, and we're going to multiply it by these conversion factors. Pints has to be on the bottom, though. 2 pints, 1 quart. Do you remember this? How we have to have them cross off? They're diagonal, so they cross. And then there are 4 quarts, 1 gallon. So then these will cross. And then if it's a whole number, you put it over 1. 12 times 1 times 1 is 12. 2 times 4 is 8. And that 1 just doesn't do anything. So this simplifies. I'm going to divide each by 4. So that would give us 3 halves, which would be 1 and 1/2. And our label is gallons. Okay. Okay. Another one. The dwarf seahorse, Hippocampus zosterae, swims at a rate of 52.68 feet per hour. Use this dimensional analysis to convert it to inches per minute. So we're going to convert this from inches, or 2 inches per minute. So one thing why we use this is because 52.68 feet per 1 hour. We use this rate because I don't know how fast feet per hour is. Not that we really know how much inches per minute, but like let's say if I want to do miles per hour, that would give me a better idea of how fast this seahorse was actually traveling. So like I said before, first we want to get our path. So we are going from feet to inches. So we know what that is. We can go to feet to inches. And then we are going to go hours to minutes. It doesn't matter which one you do first. Okay, I do have to put the feet in the bottom and the inches on the top. So in 1 foot, there are 12 inches. And then hours has to go on the top because we want them to be diagonal. Minutes is going to go on the bottom. There are, in 1 hour, there are 60 minutes. These conversion factors are always equal to each other. So now, when I take a look at this, I know that feet and feet are going to cancel, and hours are going to cancel. So what am I going to have left? I'm going to have inches per minute, which is what I want. So now I can just multiply across the top. 52.68 times 12, and that gives us 632.16. And now the bottom, 1 times 1 times 60 is 60. This is not my final answer. You need to divide the top by the bottom. So we get 10.536. and it's inches per minute is our label. In the front of your textbook, there are conversions, but just make sure that you show your work on how to get from one to the next. Okay. The next part. The next three are just solving proportions. So when you solve proportions, you just multiply the two numbers that are across from each other and divide by, I call them the odd guy out. So 9 times 3 equals 27 divided by 5. We get 5.4. Now this one's a little bit trickier because they have an expression in here. But I'm just going to show you. We're going to do 8 times 12. So 8 times 12 is 96 divided by 2. We get 48. So this portion equals 48. We have to set this equal to 48 because usually this section right here equals 48. Well, to get W by itself, you just subtract 3 from both sides. W equals 45. So once in a while you have to solve them afterwards, but not too bad. Again, doesn't matter if there's negatives in there. A negative 5 times 8 gives us a negative 40. Negative 40 divided by 2 is a negative 20. Okay. And then we're going to talk about scale models and scale drawings. You guys see these on maps, you see them in science, you see them in textbooks. Anytime you want to make something little look larger or larger look smaller, we're going to use a scale model or drawing. So the first one here, it says a scale model of a human heart is 16 feet long. So this is the model, is 16 feet. So they made it larger. The scale is 32 to 1. And when you are dealing with models and scales, it's always model to actual. They always go in that order. I also know that the 32 is the model because it's bigger than an actual human heart. So when you write this up here, when I make my proportion, I know that if this is 16 feet, they want to know how many inches long is the actual heart. Well, how many feet are in an inch? You can do this a couple different ways, I guess. You could keep this in feet and solve for this. So 16 divided times 1 is 16 divided by 32 is 0.5. So we get 0.5 feet. Well, they do want to know how many inches. So what's half a foot? 6 inches. You could have converted to inches beforehand, but it's just as easy to do it afterwards. Okay, usually I have us look in our book for this, but I'm going to have to grab our book for us. And show you guys the map here. Okay, so they gave us this map, and it gives us these 4 or 5 cities, and it gives us a scale. It says that 1 inch equals 18 miles. So if my scale is, again, map to actual, so 1 inch on the map equals 18 miles in real life. I like to write this out. It says on the map, the distance from Chicago to Evanston is 0.625 inches. So again, it's on the map, 0.625 inches. I like to label what is the actual distance. So we're going to take 0.625 times 18. Dividing by 1 doesn't do anything. We get 11.25. And the label in actual is miles. Again, we're referencing the same map, so we're going to use the same scale. Map to actual is 1 inch is 18 miles. And this time, though, it says the actual distance from North Chicago to Waukegan is 4 miles. So that goes on the bottom with the miles and the actual. It says, what is the distance on the map? So you're going to do 4 times 1, which is just 4, divided by 18, which gives us a repeating 0.2222. So it says round to the nearest tenth of an inch. So this would be 0.2 inches. So proportions are very helpful to help solve for missing information.